Okay, this is Unit 1 notes, writing piecewise functions for Advanced Algebra 2. So in order to write piecewise functions, we're going to have to break apart the graph just like we broke apart the function itself. So notice here we have three separate pieces of our piecewise function. We have a linear function here, then we have a constant function, and then we have another linear function here. So that tells us that we are going to have three different expressions. Okay, and I'm going to color code them so you can see on the notes. Okay, so since I said that first function is linear, we have to remember that a linear function is that y equals mx plus b, where b is the y-intercept and m is the slope. Okay, so if we are going to find the expression for this line, we first need to find the slope and then find the y-intercept. So notice right here we have our y-intercept of 1. And then in order to find the slope, I'm just going to use this point where the y-intercept is and then this point here. Okay, so that means I'm going up 1, 2, 3, 4, and then right 2, 1, 2. So I have 4 divided by 2, which is 2. So that means I have 2x plus 1. And then if I'm looking at my restriction, since there's nothing down here indicating that it stops, we're assuming that this goes off the graph. Okay, so we know this is going to negative infinity. But then it stops right here at 2. So this is telling us that this part of the function is going to be all numbers smaller than 2. So we write that as x is less than or equal to 2. Okay. This function here is a constant function, which means we're just going to have a number. And notice if we were to continue this all the way across, that function goes through the number 5. So we are just going to write 5. Okay, and then we look at our restriction. So right here, it looks like it starts at 2 and ends at 5. Okay, so I am going to write 2 less than x less than 5. Notice I could not include the 2 here because I already included it in this domain. That's why this is going to be less than and not less than or equal to. And I did the same with the 5 because notice this dot here is also close. I'm just going to give that to this linear line here. Okay, so again, I'm going to find, for the next function, that linear function, I'm going to find the slope. So I have 2 points. I have this point and I have this point. So up 1, left 1. So this is 1 divided by negative 1. So this is negative x. And notice I can't continue this to find the y-intercept because it's going to go off the graph. So in order to solve this, I have to use that y equals mx plus b. And I have to choose a point. So I'm going to choose the point, let's see. I'm going to choose the point 7, 3. So this point right here. And 7 is my x and 3 is my y. And then we know that my m is negative 1. So I have 3 is equal to negative 7 plus b. In order to find b, I have to add 7 to both sides, and I get b is equal to 10, which means I have negative x plus 10 to finish out my expression there. And then looking at the restriction, it looks like it's going to be all numbers bigger than 5 because it keeps going in this direction. All numbers bigger than 5. So it's going to be x is greater than or equal to 5. We're going to do the same process here, but instead of 3 expressions, we now have 4 expressions. So we have one here, which is linear. We have another here, which is constant. another here that is linear, and one last here that is constant. And again, I'm color coding so you can see each one. So since this one right here is linear, we're going to do the same thing. We're going to find the y-intercept and the slope. So I'm going to use these points here to find the slope. So I'm going to go up 2, right 3. So that means I have 2/3 x. And notice that my y-intercept crosses right there at 4. See, 1, 2, 3, 4. So I have +4. And if I was to look at my restriction, it has an arrow going there to -infinity, and it's stopping here at 0. So this is saying 0. All my numbers are going to be less than 0. So I'm going to write x is less than 0. And I'm using less than because this point here was an open circle. Okay, now let's look at the next one. This one here is a constant function, and this constant function is going to hit at 2, so I'm going to write 2. And then looking at my restriction, it looks from 0 to 1. And notice at 0, it's a closed dot, and at 1, it's an open dot. So I'm going to write 0 less than x less than 1. Okay. Then for my next one, my blue, I'm going to find my slope. So it goes up 1, left 1, which is -1, so -x. And if I continue, and let me erase some of this so we can see a little better. Okay. If I continue my slope up 1, left 1, I'm going to hit the y-intercept at 3, the y-axis at 3. Okay, so that means I have a restriction from 1 to 2. Okay, notice that my 1 is open, but my 2 is solid. So that means it could include the solid 2 from the yellow part, the yellow constant, or for this one. So I just have to keep that in mind when I'm deciding which one gets the less than and which one gets the less than or equal to. So for this, I'm just going to give them both the less than. So 1 less than x less than 2. And then lastly, that constant for the yellow, if I draw it all the way to the x-axis, it's going to hit at 1. So that's my constant function of 1. And that's going to be from 2 to 4. So 2 to 4. It's an open circle at 4, so less than. And it's going to be less than or equal to at this 2 because remember, we can't have both of them equal to the 2. Okay, this one here, we have linear and a constant. So for that linear one, I'm going to find 2 points. So I have this point here, and let's see, this point here. So I'm going to go up 4, 1, 2, 3, 4, and write 2, 1, 2, which means 4 over 2, so it's 2. So this is 2x. And notice that it crosses the y-axis at 0, so I don't need to write that plus 0. And then looking at the restriction, it goes from 2 to -5. So -5 has the closed circle, so less than or equal to x less than 2, because that has the open circle. And then this one right here is my constant function. It looks like a constant function at 6. And it's going to go from 2 to 6, both closed dots. So 2 less than or equal to x less than or equal to 6. Okay, so we took graphs, wrote them into equations. Now we're going to take word problems and write them into equations. And it's not as hard as it seems. Actually a little easier than looking at the graphs. So this one says, you determine your tax credit C based on your annual salary A. If your annual salary is below $24,000, your tax credit is based on 25% of your salary. This first one here that I highlighted in green is going to give us our first expression. Then it says if the salary is between $24,000 and $50,000, the percent drops to 20%. Okay, so that's our next expression. And then lastly, it says if you make $50,000 or more, your credit is 14% of your annual salary. So that's going to be your next one. Okay, so looking at that one, that below 24,000 gives us our domain of x is less than 24,000. And then it says 25% of our salary. Well, we know our salary is A, so we need to do 25% of A. And when we're taking percents of something, we don't write the percent in the function, we write the decimal. So the decimal version of 25% is 0.25 and then A. Well, let's just leave them all in X so we don't get confused here. Okay, so X. Okay, now looking at the next part, we have if the salary is between 24,000 and 50,000. So we have 24,000 is less than or equal to X, less than or equal to 50,000. Then the percent drops to 20%. So now we have 0.20x. Okay, we're just turning that percentage into a decimal. And then lastly, we have 50,000 or more. So X is greater than 50,000. And then we have 14% of our annual salary. So 14% is 0.14x. Now, this last one, it says a parent drives from home to the grocery store at 0.9 miles per minute for 4 minutes. This is going to give us our first one. Stops to buy snacks for a team for 2 minutes. Okay, so stops to buy snacks for 2 minutes. Okay, that's our next one. Then drives to the soccer field at a speed of 0.7 miles per minute for 3 minutes. Okay. So right here we have our 3 expressions. So the first one, it says a parent drives from home to the grocery store at 0.9 miles per minute. Anytime you see the word per, that tells you that we're going to have an X there. So 0.9x for 4 minutes. So when she leaves her home, the time is 0. Until she gets to the grocery store, her time is 4. So that means her restriction, her domain is 0, less than or equal to x, less than 4. Now she's at the store, okay? Since she's at the store, she is not going any miles per minute because she's no longer driving her car, okay? So we're going to say she has a constant of 0, right? 'Cause she's not driving anywhere. And then it says for the team for 2 minutes. So we're starting at our 4 because that's where we left off. And then 2 minutes above this is going to give us 6. So 4 less than or equal to x, less than or equal to 6. Then it says she drives 0.7 miles per minute. That's going to give us our x. So 0.7x. for 3 additional minutes. So we are starting at our 6. So 6 less than x, less than or equal to 6 plus 3 more minutes is 9 minutes. And this, it would be our answer.